Hey everyone, welcome back. Today we're diving deep into NATS JetStream to talk about one specific feature that, honestly, can totally change how you build distributed systems. It's a real game changer, and it all boils down to one simple, powerful idea.
So let's just start with this quote, because it really sets the stage. When you're looking at systems like Kafka or Pulsar or even RabbitMQ, you're often comparing things like raw speed or how they store data. But here's the thing, the killer feature, the one that really sets NATS apart, isn't about raw performance. It's all about the consumer design. And it's not just a small improvement. We're talking about a completely different philosophy for how you get access to your data.
And you know, this flexibility, it's not just a nice-to-have feature. It's a genuine superpower. Why? Because it lets you build way more complex applications using much simpler architectures. Think about it. Instead of building complicated filtering logic inside every single one of your microservices, you just let the messaging system do the heavy lifting for you. This just evaporates a mountain of upfront design headaches and complexity. So what's the big idea here? Well, the best way to wrap your head around NATS consumers is to think of them as incredibly specific windows into your data stream. Now, this is a really important distinction. See, most other systems, they just give you a fire hose, a massive, unfiltered blast of data, and then they make you do all the hard work of sorting through it. NATS is different. It lets you carve out the exact window of data you need right from the source.
This slide really just lays it all out, doesn't it? On the left, you've got that traditional fire hose model. The broker just blasts everything over the network, and your poor little client application has to drink from that fire hose and try to pick out the few drops it actually needs. It's inefficient, it's slow, and it just doesn't scale well. But now, look at the right side. The NATS window model. The client makes a very specific request, the broker does the filtering on the server side, and only the targeted messages ever get sent over the wire. It's a small change in concept, but it has massive implications for your entire architecture.
So what does this actually mean for you, the developer? Well, this server-side filtering is a huge architectural win. It means way less data clogging up your network, which means higher performance. And your client applications? They get so much simpler because you can rip out all that complex filtering logic. This is exactly why in the NATS world, you're actually encouraged to put lots of different kinds of data into a single big stream, because you know you can always carve out that perfect little window you need anytime you want with zero fuss.
Okay, so let's get into the nuts and bolts of how you actually build these windows. When you first look at a consumer configuration, you might see a lot of options and think it's overwhelming. But don't. A better way to think about it is like a powerful toolbox. Every single setting is a different tool that lets you perfectly shape how your consumer is going to behave. So, let's take a look at the most important tools in that box.
First up, push versus pull. Let's use an analogy. A push consumer is kind of like the postman just stuffing your mailbox full of letters every single day, whether you're ready for them or not. The server just sends you messages as fast as it possibly can. A pull consumer, on the other hand, is like you going down to the post office and only asking for your mail when you're actually ready to deal with it. As you can imagine, this gives you way better control. It makes it easier to scale out your services, and that's exactly why the NATS ecosystem is pretty much all in on pull-based consumers as the default choice. All right, next question. How long should your consumer stick around? A durable consumer is for your main core application services, the ones that are supposed to run forever. The server keeps track of its progress, so if your service crashes and restarts, it just picks up right where it left off, no problem. An ephemeral consumer, though, is for temporary one-off jobs. Think about running a quick report for your boss, or maybe debugging a live issue. This is so incredibly powerful because it lets you just pop in, inspect your data streams in a temporary, non-destructive way, and then it cleans itself up. No permanent infrastructure needed. The delivery policy, well, it basically answers the question, where should I start reading from? If you need to process every single message from the dawn of time, you use all. If you only care about what's happening right this second, you use new. If you need to ask a question like, what happened in the last 24 hours, that's exactly what by start time is for. And last per subject is absolutely perfect for quickly getting the most recent state or value for a whole bunch of different things. Okay, acknowledgements. This is all about the classic trade-off between safety and speed. Explicit is the safest bet. You have to acknowledge every single message one by one, which gives you the highest possible guarantee that nothing gets lost. All is a nice middle ground. It lets you acknowledge a whole batch of messages at once, which is more efficient. And then there's none. That's your fire and forget mode. It's maximum performance, pedal to the metal, but with absolutely no guarantee of delivery. It's perfect for things like metrics or reporting, where losing one message here or there isn't the end of the world. And this one, max ACK pending. This is your main dial for tuning between raw speed and strict ordering. Think of it like a checkout line at the grocery store. A max ACK pending of 1 is like having only one very strict cashier open. It's a bit slower, yeah, but everyone gets served in the exact right order. This is absolutely essential for things like state machines. But a higher value, that's like opening up 10 more checkout lanes. You get way more throughput, but the exact order people finish in might get a little mixed up.
All right, we've gone through all the tools in the toolbox. Now, for the payoff. Let's combine these settings and see how we can build 3 totally distinct, really powerful consumer blueprints that solve actual real-world problems.
First up, let's build the event sourcer. This is our blueprint for absolute maximum safety and correctness. So what's the recipe? We start with a durable consumer, because it can never lose its place. We need to be at 100% sure every single message gets processed, so we're going to use explicit acknowledgements. The delivery policy has to be all. We need to see the entire history. And then, the secret sauce. Max ACK pending is set to 1. This is what enforces that strict one-by-one processing order. And what's the result of that recipe? You get a rock-solid, bulletproof consumer that is perfect for event sourcing patterns, for state machines, or really any kind of workflow where the exact sequence of events is absolutely critical to your business logic. This is really a foundational pattern for building incredibly reliable systems.
Okay, now let's flip the script completely. Let's build something for pure speed and on-demand analytics. We'll call this one the reporter. So because this is just a temporary task, we're going to use an ephemeral consumer. We'll use a filter to only get shipped orders from the US. For max speed, we'll set the acknowledgement policy to none. After all, if we miss one data point in a giant report, it's not a disaster. And finally, we'll use by start time to look at just the last 7 days of data.
And the result of that? You've effectively just run a complex query directly on your live event stream. You are answering a real business question. How many US orders shipped in the last week without needing a separate database, without needing an ETL pipeline? Nothing. This means you can get business insights in seconds, not hours or days. It's huge.
And for our final blueprint, the lookup. This one is all about finding that one needle in a giant haystack and finding it instantly. So imagine a user wants to see the complete history of their order. We create another temporary, ephemeral consumer, but this time we use a super specific subject filter that actually includes the unique order ID. This tells NATS, hey, go find every single event related to just this one order. And what this gives you is a lightning-fast way to retrieve the entire life cycle of a single thing. You can see the order go from pending to confirmed to shipped and finally delivered. This is the perfect pattern for building user interfaces that need to show the real-time status or the complete history of a specific item to a customer.
So as we start to wrap this up, it becomes really clear that this isn't just a random collection of cool features, right? The flexibility of NATS consumers gives you a profound architectural advantage. It really changes the way you can think about accessing and using your data.
So, at the end of the day, why does all of this matter so much? Because it radically simplifies your overall architecture. I mean, think about it. We just built a rock-solid event sourcer, an on-demand reporter, and a lightning-fast lookup, and we did it all from the exact same stream of data. This means you might not need that separate database or that caching layer. And that drastically lowers your upfront design costs and lets you move so much faster.
Which really brings us to the final thought. When you have this kind of toolbox, this ability to create these precise, on-demand windows into your live data streams, what new possibilities could that unlock in your own systems? What problems that seem hard right now could you solve in a much simpler, more elegant way? It's definitely something to think about.